Hi dear students, welcome back. In the last year we studied about linear equations. Here we are going through a pair of linear equations in two variables. That is chapter 3 in your textbook. This is the part 1 video. Just go through a simple and a complicated puzzle. Here, Akhila went to a fair in her village. She wanted to enjoy rides on giant wheel and play hoopla. Hoopla is a game. The number of times she played hoopla is half the number of rides she had on the giant wheel. If each ride cost rupees 3 and a game of hoopla cost rupees 4, then how would you find out the number of rides she had and how many times she played hoopla, provided she spent only rupees 20? That's maximum amount she can spend only 20 rupees. Here, Akhila did two activities. One is giant wheel ride and other one a game hoopla. Let we denote rides as X and the number of times she played hoopla by Y. Then just go through the question. What is the first condition given in that? The first condition given in the question is the number of times she played hoopla is the half the number of rides. So we can write it as y is equal to 1 by 2 x. Y is the game played and x is the number of rides. What is the next condition? The next condition given in the question is each ride cost rupees 3 and game cost rupees 4 and the maximum money spent by her is rupees 20, only 20 rupees. So this we can write as 3x plus 4y is equal to 20. How to solve this to find the solution? That we will discuss detail in this chapter. Consider the following equations. 2x plus 3y is equal to 5. X minus 2y is equal to 3. Then we know that we can put these equations in the form ax plus by plus c is equal to 0, where a, b and c are real numbers and most importantly a not equal to 0 and b not equal to 0 and is called a linear equation in two variables x and y. Solving the linear equations, we get a pair of values, that is one for x and another for y. Also remember, every solution of a linear equation is a point on the line representing in it. Remember, two linear equations are in the same two variables, that is x and y. Then we called these equations as a pair of linear equations. Two linear equations are in the same two variables x and y. Then we called these equations as a pair of linear equation. The general form of linear equation is a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. Here a1, a2, b1, b2, c1, c2 are real numbers, and most importantly a1, a2, b1, b2 is not equal to 0. We know that graphical representation of a linear equation in two variables is a straight line. So, pair of linear equation in two variable is two straight lines. If we draw two straight lines in the same graph sheet, we will get these results. Two lines will intersect at one point, or two lines will not intersect. They are parallel, or the two lines will be coincident. That is, the value of x and y in both equations are equal, and there is a lot of solutions, infinite solutions. In the figures, you can understand the above set concepts. In figure 1, they are intersect. In figure 2, they are parallel. In figure 3, they are coincident. Now we can summarize the behavior of lines representing a pair of linear equations in two variables. Lines may intersect in a single point. In this case, the pair of equations has a unique solutions, that is, consistent pair of equations. Lines may be parallel. In this case, the equations have no solution, also named as inconsistent pair of equations. Lines may be coincident. In this case, the equations have infinitely many solutions, known as dependent pair of equations. Now we can go through little bit deeper. For that, consider the following equations. First equation, x minus 2y is equal to 0 and 3x plus 4y minus 20 is equal to 0. This is intersect. Second equations, 2x plus 3y minus 9 is equal to 0 and 4x plus 6y minus 18 is equal to 0. That is, these equations are coincident. Third equations, x plus 2y minus 4 is equal to 0 and 2x plus 4y minus 12 is equal to 0. This pair is parallel. Now we are going to check the values of a1 by a2, b1 by b2 and c1 by c2 in these three equations. This table gives you a clear picture. In the first pair of equations, a1 by a2 is 1 by 3, b1 by b2 is minus 2 by 4, c1 by c2 is 0 by minus 20. So here a1 by a2 not equal to b1 by b2. That is intersecting lines. So exactly one solution may occur. This is unique solution. In the second pair, a1 by a2 is 2 by 4, v1 by b2 is 3 by 6, and c1 by c2 is 9 minus 9 by minus 18. That means here a1 by a2 is equal to b1 by b2, that's equal to c1 by c2. That is coincident lines. It has indefinitely many solutions. So in the third pair, a1 by a2 is 1 by 2, b1 by b2 is 2 by 4, and c1 by c2 is minus 4 by minus 12. Here a1 by a2 is equal to b1 by b2, but not equal to c1 by c2. So this pair is parallel lines and has no solution. From the above discussions, we can generalize if the lines represented by the equation a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0, then if the lines are intersecting, then a1 by a2 not equal to b1 by b2. If the lines are coincident, then a1 by a2 is equal to b1 by b2, that's equal to c1 by c2. If the lines are parallel, then a1 by a2 is equal to b1 by b2, that is not equal to c1 by c2. Now we can solve a simple question. Check graphically whether the pair of equations x plus 3y minus 6 and 2x minus 3y is equal to 12 is consistent. If so, solve them graphically. The solution. Here given that x plus 3y is equal to 6, that's the first equation, and 2x minus 3y is equal to 12, that's the second equation. From equation 1, we can find y is equal to 6 minus x by 3, and from equation 2, y is equal to 2x minus 12 by 3. Give any two values for x and find the values of y in both the pairs. In the first equation, we will give x is equal to 0 and 6 as the values. Then the corresponding y values are 2 and 0. Same method. In the second equation, we will give x is equal to 0 and 3. Then y is equal to minus 4 and minus 2. Then we plot a 0, 2, b 6, 0, p 0, minus 4 and q 3, minus 2 in a graph sheet. The graph sheet is shown here. So we will get two lines AB and PQ. Here we can see that B6, 0 is the common point to both the lines AB and PQ. So the solution is x is equal to 6 and y is equal to 0. And the given pair of equations is consistent. Dear students, that's all for this video. In the next video, we will discuss about algebraic methods of solving a pair of equations. Stay tuned. Thank you. Please subscribe, share and like our channel.